So, if we may continue from where we stopped yesterday, I will advise you that as you are going to school, my son, you put your attention on what you are being taught. Because most of us, we are not privileged to go to school. Now, we sold most of our properties to send you to this college. Please do not follow bad friends. Always do your assignment. Study hard. Study hard, because that is what will distinguish you from every of your classmates. Please promise us that as you are going, you are not going to join bad gangs, and it shall be well with you, my son. Oh, hello guys. Let's start today's lecture by talking about also dimensional analysis. But this part of dimensional analysis we are going to talk about is the use of dimensional analysis to derive the exact form of a relationship between measured quantities. Now, before we continue with this lecture, please make sure you subscribe to this channel, turn on the notification button, and also share this with your friends. You can't be the only one enjoying everything here. Share it with your friends, share it to everyone in your department so that they will know what is happening. Now, may we continue. Dimensional analysis, talking about also dimensional analysis. But this part of dimensional analysis we are going to talk about is the use of dimensional analysis to derive the exact form of a relationship between measured quantities. Now, before we continue with this lecture, please make sure you subscribe to this channel, turn on the notification button, and also share this with your friends. You can't be the only one enjoying everything here. Share it with your friends, share it to everyone in your department so that they will know what is happening. Now, may we continue. Dimensional analysis can be used to derive the exact form of relationship between physical quantities. This is one of the uses of dimensional analysis, or one of the use of dimensional analysis that was outlined before now. Dimensional analysis can be used to state the exact or to derive the exact form of a relationship between measured quantities. Now, for instance, if I give you F is equals to mv square all over r. Now we know that this F means force, this is mass, this is velocity, and this is radius. Now there is a form of relationship between F, between m, and between what? V. And that relationship is that F is equals to m raised to the power of 1, V square, and arrow is under raised to the power of what? 1. Which arrow can also be written, or this can also be written as m raised to the power of 1, V square, and then arrow minus 1. From the laws of indices, if you have arrow minus 1, this can be written as 1 all over arrow. So when this is written as 1 all over arrow, this gives us m raised to the power of 1, V square, times 1 all over arrow. And this gives us mv square all over arrow. So we can say that F is related to m, v, and arrow using the relation where our m is raised to the power of 1, v square, and then arrow raised to the power of minus 1. So let's solve some question in order to understand better how we can use dimension to determine or to derive the exact form of relationship between the physical quantity. Now let's start the journey. You are given a question. The question says, suppose the period of oscillation T of a simple pendulum. The period of oscillation T is the period of oscillation of a simple pendulum depends on the mass of the bulb, the length of the thread. So we say the period T is dependent on the length of the bulb, of the thread rather. Then the mass, first of all, it was dependent on the mass. So let's write M first. It was dependent on the mass, then dependent on the length, and then dependent on the acceleration due to gravity, G. Use the method of dimension to estimate the value of X, Y, and Z. Given the relation T is equals to K. Now, the relation given to you is T is equals to K raised to the power of, or K times M raised to the power of X, L raised to the power of Y, and G raised to the power of Z. Now, whenever you are given anything like this, how do you solve an equation like this? Let's start by saying that our T is K to the power of, then M to the power of X, L to the power of Y, and G to the power of Z. Now, what is the mass? What is the length? And what is the acceleration due to gravity? Now, when you are deriving the exact form of a relation, the three fundamental quantities, mass, length, and time, must be at either sides of the equation. They must be at this side and they must also be at this side. Now, if you don't have any of them at one point of the equation, what do? You introduce them raised to the power of 0. If you don't have, what I mean is, if you don't have mass, length, and time, any of these ones, maybe you have length, you don't have mass. If you have time, you don't have length. What you do is introduce the ones you don't have at the left-hand side of the equation by raising it to the power of what? 0. And then breaking every physical quantity there into their base dimension. When you say their base dimension, means break them down into mass, length, and what? And time. So this will give us, we have T here, but we don't have M. We don't have L, and we don't have, but we have T. We don't have M. We don't have L. So since you don't have M, you raise M to the power of 0. You don't have L. You raise L to the power of 0. You don't have T. You raise T to the power of 1. T raised to the power of 1. Now, why do we do that? M raised to the power of 1 is 1. M raised to the power of 0, right, is 1. L raised to the power of 0 is 1. And T to the power of 1 is what? Is T. Are we getting it now? So 1 times 1 times T will give us T. Now this will be equal to. Now what are we supposed to have here? This will be K. The dimension for M, which is mass, is already given as M. So you raise to the power of X. Dimension for L, the length, is already given as what? L, raised to the power of Y. Now the dimension for G. G is the acceleration due to gravity. And dimension for acceleration and acceleration due to gravity is the same. And the value is LT minus 2. If you've not watched our previous video, please do well to watch that one before coming here. So in place of G, we are going to put LT minus 2. So we say times, we have in place of G, LT minus 2, everything bracket raised to the power of what? Z. So all we need to do now is collect like terms here. You may want to remove the K because it's a constant. It doesn't really matter. So this gives us M raised to the power of L, 0 rather, L raised to the power of 0, T raised to the power of 1. And this will be equal to, this will be M, we said K is dimensionless, so you can remove it, M raised to the power of X times L raised to the power of Y times, use Z to open through the bracket. L to the power of Z is what? LZ. Then T minus 2 times Z is what? 2Z. Okay? Now, we now collect like terms. This becomes M to the power of 0, L to the power of 0, T to the power of 1 is equal to M raised to the power of X times L, Y plus Z, because the bases are equal. L and L is present here. The bases are equal. What do you do to the power? You add them. So this gives us y plus z. Then we have t minus 2z. Now, at the end of the day, what are you going to do? You now compare both sides of the equation. Compare both sides of the equation. Now, how do you compare both sides of the equation? By equating what you have here to what you have here. So we are going to equate mass first. You now say, what is mass here is raised to the power of what? 0. Will be equal to, mass here is raised to the power of what? X. Bases are equal. You can cancel that. So m cancels m. Your x is equal to 0. So you have your s as equal to 0. Now let's equate the next dimension we have there. The next dimension we have there is what? Length. Is L raised to the power of 0 is equal to. Now, at this point of the equation, what do we have? L raised to the power of y plus z. So what we do is equate each of them. Equate each of them. Are we getting it? Equate each of them. M raised to the power of 0 will be equal to m to the power of x. L raised to the power of 0 will be equal to L raised to the power of y plus z. Now, at this point in time, the bases are equal. So what do? We cancel that. And then 0 will be equals to y plus z. So we can say y plus z is equal to 0. And you say this is equation 1. Bam! So you keep that one first. Okay, clear? You keep that one first. Now, the next case that we are going to take now is t. Now, what do we have as t here? Comparing both sides. You have t raised to the power of 1 is equal to t raised to the power of minus 2z. T to the power of 1 is equal to t to the power of minus 2z. Bases are equal. You can cancel that. So 1 is equals to minus 2z. 1 is equals to minus 2z. 1 is equals to minus 2z. Now divide both sides by minus 2 to get your z. Divide both sides by minus 2 to get your z. So your z is equals to what? Z will be equals to what? Now, I see you answering it in your mind. I see something in you, but I don't know what it is. So, Z here will be equals to minus 1 all over 2. Minus 1 all over 2. Okay, clear? So, you have your S as equal to 0 and your Z as equals to minus 1 all over 2. That's what we have here. S is equals to 0. So, we may need to write it out here. S is equal to 0. Z is equals to minus 1 all over 2. But you don't know what y is. You don't know what y is. But you need to know the value of x, y, and z in order to know the relationship that t has with each of these quantity. So, let us look for what y is. Now, from equation 1, so we may come here and say from equation 1, y plus z is equal to what? 0. From equation 1, y plus z is equal to 0. From equation 1, y plus z is equal to 0. Now, if y plus z is equal to 0, and you already have notes, you now write down notes, your z is equal to what? Minus half. Now, it makes sense, right? Your y plus z is equal to 0. Note z is equal to minus half. Now, substitute z equals to minus half into this equation. So, in place of z, we can put what? Minus half. So, this gives us y plus, what do we have? Z. Now be minus half. Everything equals to 0. And this will now give us y. Plus times minus is minus half is equals to 0. And y will be equals to, if minus half cross to this side, becomes what? Positive half. So we've gotten all our values. Our s is 0, y is half, and our z is minus half. Now note, initially, the relation was given as what? T is equals to k, m raised to the power of x, n raised to the power of y, and g raised to the power of what? Z. So we come here and write. The relationship was given that t is equal to k, l to the power of m to the power of x, then L to the power of y, and G to the power of z. So what we are going to do here is, in place of x, y, and z, we are now going to put their values. So t will be equals to k. Now, m, what is s? 0. L, what is y? Is half. Then g, what is z? Is minus half. And this will become k. Any t raised to the power of 0 is what? Is 1. M to the power of 0 is what? Is 1. So everything here gives us times 1. Then we have L raised to the power of half times G to the power of what? Minus half. And T will be equals to K times 1 is K. L to the power of what? Half. Then times G raised to the power of minus half. What does this mean? That whenever you have A to the power of n is the same thing as 1 all over what? A to the power of n. So if you have G to the power of minus half, it's the same thing as what? If this minus must leave, it comes here as 1 all over G to the power of half. Are we getting it now? So if I give you something like m to the power of minus half, what will it become? 1 all over m to the power of what? Half. What's it clear? It's very easy. It's very easy. So we now come here and say this will be what? Times 1 all over G to the power of half. Now, L to the power of half times 1 will give us T is K. L. This times 1 is half all over. Then G times, of course, we know that everything here will be over 1. This times this will give us G to the power of half. Now, there is a lot of indices that says that if you have the same thing on both sides of the equation, like up and down, numerator and denominator, you can put them in a big bracket and let it be 1 on top. So if I have something like A over N all over B over to the power of N, rather, according to the law of indices, this will be what? A over B to the power of what? A big bracket, then what? N. So what am I going to write here? This becomes K L all over G to the power of a big bracket, or let's say a big bracket, then raised to the power of half. And this will be our answer. But we know that anything raised to the power of half is what? For instance, if you have A raised to the power of half, it means for square root of A. So if raised to the power of half is here, it means the square root of everything we have here. So our final answer will be T is equals to K L over G. Sorry, this is Q. L over G, then a big square root. And this is the exact form of relation. Let me write it here. T is equals to K L. This L over G, the square root of everything here. And this is the exact form of what? Relation. And this makes sense. If you've done your physics practical before, the simple pendulum experiment, you are given that the period of oscillation T is 2 pi root of L all over what? I don't know why I keep writing Q. All over Q. Here your 2 pi now is a constant K. 2 pi is a constant K. Are you getting it now? So that is what they expect you to do. Now, in an exam condition, they will ask you the same question. They will now ask you, find the value of S, Y, and Z. That is what you are expected to do. Check it now. The value of S, Y, and Z will be S is equals to 0, Y is equals to half, and Z is equals to minus half. And you have done that. Simple and short. Simple and short. This will be the answer. Now, if they say the exact form of relationship, you now come down until you get to this point. What's it clear? Now, let's continue with another example. Now, you are given this question. I once said that whenever you see this question, what should come to your mind is, it will come out the same way. It will come out the same way. The answer is X is equals to 1, Y is equals to 1, and then Z is also equals to 1. Ys is equals to 1, y is equals to 1, and z is also equal to 1. Now, why is it like that? Why is it like that? Let's solve. Let's solve this one. Then we know that we are done with dimensional analysis. Now, we are going to take this one step by step and very easy. You are given that the force, consider a small ball of radius r falling through a viscous liquid of viscosity with a velocity v. Determine the exact form of relation between the viscous force, so you are given the viscous force experienced by the ball, and r, then viscosity, and v for velocity. Given that f is equal to k r raised to the power of x, viscosity raised to the power of y, and velocity raised to the power of what? Z. Where k is a dimensionless constant, and s, y, and z are to be determined by the method of dimensions. They are to be determined by the method of dimensions. Now, what are we going to do? Let us take a case study here. Let's do something. We have force as the first thing given to us. Our force, dimension for force is mass times what? Acceleration, isn't it? Dimension for mass is m. Dimension for acceleration is lt minus 2. So the dimension for force is mlt minus 2. We now come back and impute that one here. So in place of force, we have mlt minus 2. This will be equals to, now we say we can remove k. What is the dimension for radius? Radius is length. Like I told you, that radius is the distance from the center of a circle to the circumference. The distance from the center of a circle to the circumference is called the radius. Now, like I was saying, the dimension for radius is L. Now, L is raised to the power of what? Radius is raised to the power of x. So your L, get out, will be raised to the power of x. Get out, get out. Then we now have viscosity. Now, the question is, what is the dimension for viscosity? We said viscosity is force over area times velocity gradient. Let's use Vg. We've done this before. If you've not done this, please make sure you watch the episode 1 of this lecture. Force over area times velocity gradient. Dimension for force, as we just said, is mlt minus 2 all over. Dimension for area is L square, and dimension for velocity gradient is t minus 1. Why? Because velocity gradient is velocity all over length, and dimension for velocity is lt minus 1. Dimension for length is L. This cancels this, so you are left with t minus 1 for velocity gradient. It's as easy as that. So if we do this algebra here, or this arithmetic, what are we going to have? We have ml. If this one comes up, becomes everything here becomes minus 1, then t minus 1. And this is the dimension for viscosity. So we come back here and say dimension for viscosity. This is viscosity, please note. So we say this is times ml minus 1, t minus 1. Everything is raised to the power of what? Y. Then times dimension for velocity is what? Lt minus 1. Dimension for velocity is what? Lt minus 1. Now this is raised to the power of what? Z. So in this part of the equation, you see that you have m, you have L, you have t. So you don't need to raise anyone to the power of what? 0. Now note that m standing on its own means m raised to the power of what? 1. L standing on its own means L to the power of 1. And then we have t minus 2 equals to this. So this gives us mRt minus 2 is equals to L to the power of x times, use this m to open through, you have m to the power of y, L to the power of minus y t to the power of minus y times, then we have L to the power of z, t to the power of minus z. At this point in time, what do we do? We have ml t minus 2 will be equal to collect like term. Let the m comes first because the arrangement is usually mlt. Very easy. The arrangement is usually mlt. So let the m come first. And this becomes m to the power of y. Then L will follow. What do we have here? L to the power of what? X. Then we have what? Times L to the power of minus y. Then we have another L here. Times L to the power of z. Times the next one is t. T to the power of minus y. Times t to the power of minus z. And what are we going to have? This will now be mlt minus 2 is equal to, then this gives us m to the power of y, then times L. Now the bases are equal. What do we do to the power? You add them up. Bases are equal. What do you do to the power? Add them up. So this gives us s plus times minus y will give us minus y, then plus z times t. The bases are equal. What do you do to the power? You add them up. And this gives us minus y plus times minus z is minus z. Very easy. Now, at this point in time, now you can now compare. You can now compare both sides. Now, comparing both sides, what are we supposed to have? Comparing both sides, what are we supposed to have? Let's go to a clean sheet. Comparing both sides. Let me rewrite what we have here. We have mlt minus 2 is equals to m to the power of s times L to the power of x minus y plus z. We have here x minus y plus z times t. What do we have for t here? Minus y minus z. So we have it as minus y minus z. Now comparing both sides, we are going to compare m first. So m here is just standing m must be equal to m raised to the power of x. Bases are equal, you cancel. So your s is equals to 1. Now the next word is what? L. L will be equals to L x minus y plus z. Bases are equal, you cancel. When this cancel here, what are we left with here? 1. Because this L is raised to the power of 1. So we have 1 is equals to x minus y plus z. And we can now say that x minus y plus z is equals to 1. This will be your equation 1. Now the next one we need to compare is t. This is t to the power of minus 2 is equals to t to the power of minus y minus z. The bases are equal, so you cancel that. And this gives us minus 2 is equals to minus y minus z. So we have minus y minus z is equals to minus 2. And this will be equation 2. So we have different equation now, but at least we've gotten one. The first thing that we got is x is equals to 1. So we must get, let's say, z and y. Now, how do we get each of these ones now? Are you sure that there is not a mistake somewhere? Are you sure? Sorry about that. This m here is raised to the power of y. The m here is raised to the power of y. So everything here will be what? Y. So y and y is equals to 1. And if y is equals to 1, it means here y is equals to 1. Because I know that's how it ought to be. Now, from equation 2, can I take it? From equation 2, minus y minus z is equals to minus 2. Minus y minus z is equals to minus 2. But you already have your y. Note that y is equals to 1. So in place of y, we can put 1. And this becomes minus 1 minus z is equals to minus 2. Is that not clear? Now, take minus 2 to this side and then take minus z to this side. What are we going to have? We have minus 1 plus, if 2 is coming here, it becomes plus 2. And if minus z is leaving here to this side, it becomes what? Positive z. So, equals to z. Now, minus 1 plus 2 is what? 1. So, 1 is equals to z. And z is equals to 1. Now, the next thing we are going to take is to get x. You got to your z as also equals to 1. So, how do we get s? Now, note, from equation 1, we have x minus y plus z is equal to 1. So what are we going to do now? We substitute each of them into the equation. We are looking for s minus y is what? 1 plus z is what? 1. Everything must be equals to 1. And then s minus 1 plus 1 is 0 equals to 1. Now s plus 0 is what? X. So x is equals to 1. So now let's finish up in this small box here. You will now agree with me that everything, like I told you from the initial point, is x is 1, z is 1, and y is 1. And you are given f is what? K arrow x, this y, and then vz. So substituting in, what are we going to have? K r raised to the power of 1, this raised to the power of 1, and v to the power of 1. And then f will be k arrow this and v. And this will be the final answer to this question. So that's the final answer to this particular question. Okay. Now let's take the last question for this category. Then we know that those two questions are enough. If you want to practice more, please make sure you practice more. Thank you for your time. And make sure you share this video to your friends. You should try this one. Try this one at home. It's a very simple question. The question says the period of vibration T. Period of vibration T. Period is given to you T of a liquid depends on the density. You're given the density, the radius, and the surface tension. So this will be X, Y, and what? Z. Now, what is the dimension for period? Is T. Dimension for density is ml minus 3. Dimension for, this is raised to the power of what? X. Dimension for radius is L raised to the power of Y. And dimension for surface tension. Surface tension is force over length. And this force is mlt minus 2. Length is L. L cancel L. This gives us mt minus 2. So the dimension for surface tension is mt minus 2 raised to the power of z. So as a matter of fact, you now have t is equals to, use s to open through. This gives us m raised to the power of x, l raised to the power of minus 3x times l raised to the power of y. Use this one to open through. You have m raised to the power of z, t raised to the power of minus 2z. Now, if you see this side of the equation, you don't have m, you don't have l, but you have t. So you raise those one to the power of 0. So m raised to the power of 0, s to the power of 0, t to the power of 1 is equals to, collect like terms. Let all the m come to one side and all the l go to one side. So this gives us m raised to the power of x times m to the power of z times l to the power of minus 3x times l to the power of y times t to the power of minus 2z. And at the end of the day, you have m to the power of 0, l to the power of 0, t to the power of 1 is equals to, the bases are equal. So what do you do to the power? You add them. X plus z times l, then this gives us minus 3x plus y times t minus 2z. And then finally, what are we going to have? You have m to the power of 0 is equals to m to the power of x plus z. Compare both sides of the equation. This cancels this. I'm very fast because I expect you to do this yourself. This gives us x plus z is equals to 0, equation 1. Okay? Now, the next one we are going to compare is this. Is L to the power of 0 is equals to, we have L to the power of minus 3x plus y. So when these two cancels out, what are we going to have? You have 0 is equals to minus 3x plus y. We say this is equation 2. And finally, we are going to compare t. T is equals to what? 1 raised to the power of 1, and then t is minus 2z. So when these two cancel, you have 1 is equals to minus 2z. Divide both sides by minus 2. This cancels this, and your z is equals to minus half. So you've gotten your z. You don't have your x. So what do? Say x plus z is equal to 0 from equation 1. S plus z is equals to 0. S plus z is equal to 0. S plus z is equals to 0. Now, what is your z? You calculated your z as minus half. So this gives us s plus bracket minus half equal to 0. And this becomes s plus times minus is minus half is equals to 0. And x is equals to what? Half. And that is your value for your x. S is equals to half. X is equals to half. Now, the last thing you are going to do is to find y. But we know from equation 3 or from equation 2 that minus 3x plus y is equals to 0. Minus 3x plus y is equals to 0. Now, your s is what? Half. So this becomes minus 3 bracket half plus y is equals to 0. Minus 3 times half is what? Minus 3 over 2 plus y is equals to 0. So your y is equals to what? If minus 3 crosses to this side, becomes 3 over 2. Okay? Now, your t is equal to your density. Of course, you have your constant. Then raised to the power of what? X. Then what do we have? Radius raised to the power of y, and then surface tension raised to the power of z. So finally, your answer will be t is equals to k. Now, your density, your x, where's the value for your x? You calculated s to be what? Half. So this is half. Your y is 3 over 2, and your density is minus half. I mean, your surface tension, not density, is minus half. Now, this will become t is equals to k. Density is half times arrow 3 over 2. Then times, now, if this one wants to come down, becomes 1 all over this raised to the power of half. Please take note between the radius. I'm writing them almost the same, but they are not the same. Between the radius and this. And this will become t is equals to k. Then we have density to the power of half. This is on the denominator. So you have arrow to the power of half. Then arrow. This is surface tension. Please take note. It's a different arrow. Then arrow to the power of 3 over 2, which is the radius. Now, note that 3 over 2 is the same thing as what? 3 over 2 is the same thing as half times what? 3. Same thing as what? Half times 3. So we can write this as k. Then we have density, half, times radius. Then we can say this is our half times what? 3. Are we getting it now? Because 3 times 1 is 3, then over 2, all over, then this surface tension over this. Now, at the end of the day, what are we going to have? Now note that everything here is having half, half, and half. We say when anything is having half, what do? You put square root. So we can say this is T is equal to the square root of the density. Then we have the radius, but the radius is raised to the power of what? 3. Why? Because you have half here, then you have 3. The square root is covering the half, then you have the 3 also outside. Then this is divided by the surface tension. And this is the exact form of relationship. Of course, you know that there is a constant here. So your T is K root density radius 3 all over the surface tension. So that is how to solve the problem like this. I've really helped you to solve this one. So you will try this one as your assignment. You try this one as your assignment. So that will be the end of this lecture. Thank you for your time. And make sure you share, subscribe, and comment below your experience of the lectures, areas that you would want us to improve. Thank you for your time, and God bless. Bye-bye.